Well, C only has one line and the rest of them have two.
Okay, so C actually has two lines overlapped on this. So there's the sort of the outer one and then that nested one inside there. They're overlapping or on top.
Oh, okay.
What else do you see, or what else comes to mind when you look at this one here?
I'm not really sure.
Okay. What about in D? Is it two lines in D? Or is it a line and something else?
It's a line and something else.
Yeah, and so these actually intersect twice. How many times does letter B intersect?
Once.
Once. How about A?
They don't intersect.
So no intersection. Very good. Okay. And C, if we were to give it a word, we would say intersects everywhere. Is that okay so far?
Mm-hmm.
Okay. So no solution literally means there are zero intersections. Zero intersections. Nothing more, nothing less. One solution is one intersection. So the one that has no solution is the one that has no intersections or zero intersections. Does that help to answer this question?
Oh, so it's A.
It's A, yeah. Now, if it was the wording was changed to one solution, which would be the correct answer?
One solution. Letter B.
Okay, how about two solutions?
Letter D.
Okay, and C would be infinite solutions for letter C. So what you have to do is somehow commit to memory that parallel lines on the top left here, they have no intersection. They have no place where they intersect. So they have no solution. Most systems have one solution. That's kind of what we looked at yesterday, last night. A parabola and a line could intersect twice. That's what the case is here. But two overlapping lines, they have infinite solutions because they intersect everywhere. So I'm not sure if this is what you had in mind, but that's kind of our first starting graph picture. I think that's what you meant here by this. Okay, let's look at another kind of graphing problem. I'm going to rephrase the question here, but I'm going to grab this graph and just ask you some things about it that could be useful here. All right, so the first thing I want to ask you is, what is the y-intercept?
It's the 0.04.
Very good. Very good. Okay. How about what is the slope? It's always okay to count. It's fair. It's reasonable strategy here. If your screen, if it's, I don't know if it's small on your screen, but you can count boxes up and then to the right.
Um, 5/4.
Yeah, the slope is 5/4. So let's say I wanted you to find the equation of a line. And you know the y-intercept and the slope. Do you remember which equation would be best for that?
The equation of a line.
Yes, there's a couple different equations of the line, but when you're given the y-intercept and the slope, there's kind of a preferred one.
Y equals mx plus b.
Very good. And your slope is 5/4. And your b is 4. Could you use this equation to determine the x-intercept? If it's not clear what I'm asking, please let me know that, but 4 is the y-intercept, but what is the x-intercept?
Would you solve for x from that equation, or I'm
After,
kind of
yeah,
confused.
yeah, so x-intercept means y is 0. So yes, you solve for x.
Okay.
Because if you go back to the graph, and I'll come back to the question, you don't have the x-intercept. It's between -3 and -4, and that wouldn't be an answer. It would want that value. So could you solve this for x, please, after setting y equal to 4?
-16/5.
Yes. Very good. Okay. Any questions kind of on that? Because we're going to use that information for the next couple of problems. Any questions on anything we did there about finding, we found the y-intercept, we found the slope, we found the x-intercept after writing the equation of the line.
I don't have any questions.
Okay, good. Are these the type of graphing questions you're thinking of, or did you want something like more of like a story problem or an application problem?
I was thinking of this, but if we could also do a few questions like that, that'd be great.
Yes, of course. Okay, so ignore what's down here at the bottom. I want you to find the x-intercept, the y-intercept, and the slope of this, please. Any questions for me on this one, Julia?
No,
Do you need some more time, or do you have some answers?
I have the answers.
Okay, let me know. What do you got here?
For the x-intercept, I got -2.
Okay. So it is -2, but I've just read it as an ordered pair. Go ahead. Sorry.
Okay. For the y-intercept, I got 4, 0, 4.
Okay, good. Slope.
2.
Very good. Okay. So that's not too bad at all. So of course you might get something a little more difficult, like the one I'm going to give you now. This one is only asking for the slope. So let me
Okay.
get this question in, just the slope. And you might think, great, I'll just count boxes. But unfortunately, you can't count boxes. You could try really hard to like pick spots that you know are on there. I probably would just tell you to use 2 of the ordered pairs.
Okay.
So it doesn't really matter which ones you use. They're all bad. I guess I would probably go for this one, these 2 that I'm circling. And the reason is because it's y minus y and the y values both have a denominator of 5. That might be a reason to do that one. And then the 9 and the -6, they're both whole numbers.
Mhm.
But this one's not great. No calculator on this one, although you do get the calculator on there. So I guess you can, if you want to use your calculator, do this. But give this one a try, please. I'm gonna just start writing down the steps here, just in case there's any questions here on this one. The order does not matter unless you somehow switch them. You have to switch them both, or not just one or the other. How are you doing on this one?
I got 6.66.
Okay. Did you use 3/5 as y2 and -27/5 as y1?
Yes.
Or did you go the other way?
I have it the same way that's on the screen.
Okay, very good. So 3 plus 27 is 30, 30 over 5, that's 6. And then the 9 minus a -6 is 15. Maybe we got, so if you did all this, that's, I mean, you're almost there. 30 over 5 is 6, 6 over 15. We can reduce that to 2/5. Is that okay? Is that clear?
Yeah.
All right.
Yeah.
So you definitely have the slope formula down, because sometimes you cannot just count squares. All right, let's look at a couple more of these before we move on to some applications of these. But this one, it gets snipped in here. Again, you're going to be multiple choice, but we're mentioned yesterday, it's better to try to really, if you can, just work them out. So this one, it says line L is shown in the XY plane. There's line L. And the point with coordinates 2C is on line L. So the problem is, like, we don't know where that is. Like, we don't know if that's, 2.5, 2.6. It's probably a fraction. So we can't we can't get it directly. But what you could do is write the equation of the line. And I already asked you this earlier. What's the kind of the easiest one, the one you hope to be able to do? Mx plus b.
Mhm.
So this one, the reason that's so valuable here is you know b, and you can figure out the slope. You see that? You could figure out the slope here.
Mhm.
So your b is 4. I'll let you figure out the slope here. But once you get those values, you just have to substitute x equals 2 into the equation. So I'm
Okay.
asking you to calculate the slope, then to put 2 into the equation and tell me the result for y.
Is the slope 1?
It is not. It looks like 1, but I would go down. See, I would go to the nice points, the ones that are solid, like down and then right,
Oh, okay.
all the
Okay.
way to the ones they've got to hit perfectly. Like, don't take any chances on this.
-4/5.
Okay. So you're going to put that back into the equation. For m, you have your b value, and you're going to use x equals 2. And you're welcome to use a calculator, because I believe you'll have one for this part of the test if needed.
2.4.
Yes. Okay. So let's move on to some more of these, to just a little, kind of increase the difficulty stuff. Again, they can't ask you too many complicated things in this short amount of time, but sometimes they just give you a lot of things to think about here. Okay, the graph of the function f defined by f of x equals -1/2 x minus 4 squared plus 10 is shown in the xy plane. It's a parabola, it opens down. The vertex, could you tell me the vertex from this or from the graph?
Is it +10?
It's the vertex is always an ordered pair. There's an x and a y value. 10 is part of it.
4, 10.
Yes. Very good. And you can also see it kind of right there. Okay. If the function g not shown is defined by -x plus 10, so let's look at that. Y equals -x plus 10. What is its slope and what is its b value?
This- the b is 10,
Okay, I agree.
and then
What is the number in front of x?
is it -1?
Yes. Now, in terms of a slope, that means it's more like this, because you're going to go down 1, right 1. Okay, so you start at the b value, you go down 1, right 1, down 1, right 1, down 1, right 1. And I presumably assume it's asking, where do these things intersect?
Mhm.
And they intersect right there. What is the x value there?
1.5.
Yes, 3/2. Okay, let's look at kind of an application problem, but the same kind of scenario, different things here. Make this a lot bigger so you can see it. Okay. So there's lots of questions I can ask you here. I probably should ask a few of them. Where is this graph increasing? And I'm looking for the between 2 years, or between which 2 years is it increasing?
It increases from year 1916 to 1926.
Very good. And that's because it's going up and to the right. Where is it decreasing? Yeah, where is it going down and to the right?
Down to the right. Well, it goes down the rest of the way. So can I say like 1926 to 1976?
Yes. Yes. And really it's I don't know why they would. Anyway, so avoid what I just did, which is you don't want to start thinking about these things like, why are they talking about railroads in the United States? I mean, this is so old, like just focus on what they're asking you to do.
Mhm.
Let's find the slope. I want you to find the slope from 1916 to 1926. Now try not to get overwhelmed by the size of the numbers and the years. Like 1916 to 1926 is 10 years.
Mhm.
And that's the, I mean, on the bottom, it's the 1926 minus the 1916, but it's really 10. And the numerator do the same thing. But again, try not to focus on all the zeros. It's 421 minus 397, but you're going to have some zeros at the end. So go ahead and figure that out for us, please. The change in y, the height.
Is it 24,000 over?
Yes. And then the over 10, what it does is it cancels one of the zeros. Okay. All right. So now let me ask you to do another question with the same graph here. Let's have you find the slope from 1946 to 1956, please.
The final reduced answer is negative 3,300 over 1.
Yeah, that 30, yes, 3,300. Wait a second. You're going from 46 to 56, right?
Yes.
Okay. Yes, that's correct. Very good. I was mostly interested in the sign that you got that down, because that's key. Very good. Okay. All right. Okay, so I've got a new question here, but I want to ask you a few questions because they're really these are the questions that things you should be thinking about when you see something like this. How would you describe this thing right here? How would you describe that?
Um, it's a line segment that's going up and to the right.
So it's a line. And the equation of a line is y equals mx plus b. Would you agree with that?
Mm-hmm.
So it has an intercept and a slope. Okay, so now we're going to look at the answers. And I want you to consider the picture that we just on the left here. Let me consider that it has both an intercept and a slope. In fact, maybe you can tell me the intercept of the graph.
Is it letter B?
It's either B or C. Okay, and it comes down to the slope here. 3/4 up 3, right 4. You got it. Good. So try not to get overwhelmed, like if it's different letters or something. Like sometimes you'd be like, well, what is it? What is it? What is it? What is it? What is it here? We're not going to do this problem, but I want you to see a graph like this. And that was the whole point of this first part of the lesson was like when you see a line, you should run through like all the things that we just talked about. What's the slope? What's the b value? If it's got a y-intercept, which is the b value, if it's got an x-intercept, one of these is almost always the answer in these questions.
Mm-hmm.
You know, you don't have to be time to be writing the equation and setting it in standard form, things like that. Okay. So we did some linear graphs. Do we need to do like more quadratic graphs? Should we switch topics? What do you think here?
Can we switch topics?
Yes. Anything come to mind that you would like us to work on?
Not really.
Okay. We started doing systems a little bit yesterday. I think we should just do a couple more of those problems for systems just to get that figured out. We did these yesterday. Okay, let's look at a couple of systems here. All right, so here's a system of equations. What method do you think is the best to solve this system the way it's presented here?
I would say make the top one negative so it could cancel and you can solve for it.
So you're trying to use elimination on this one.
Mm-hmm.
And elimination does work. However, because it's already solved for y, you generally use substitution. You generally take this and put it back in for the y value. Generally.
Okay.
Is that clear?
Mm-hmm.
Ish. Okay. So it's 2x plus 4 times x plus 2 equals 8. So you take that that given value for y and plug it in the second equation. This is a substitution problem. Okay, and then from here you distribute, combine like terms, and solve for x. So could you solve this for X for us, please?
X equals 0.
How did you come up with that?
I distributed the 4 and I got 2x plus 4x plus 8 equals, is it equals 0?
Equals 8, sorry. Yeah, just
Oh,
making sure. I
equals
want
eight,
to.
okay.
I want to hear. Yeah, I want to hear the right steps because that was said so fast. I was like, "Wow, that's incredible." It is 0. I just wanted to make sure you actually distributed in
Yeah.
for this. Okay, perfect. Now, how would you find the value of y?
To find the value of y, you would go, I think the top one would be the easiest, so it
Yes,
would be 0 plus 2, which is 2.
great. So sometimes you're solving for one of the variables, sometimes the other, sometimes both. Sometimes they even ask you to add them together. We have no idea what to expect, but you just have to work through that. Okay, so the other approach to solving a system of equations is elimination. The times you would use elimination are generally when they're in standard form, but you generally don't get them in like just perfect standard form because they're always throwing a little wrinkle at you.
Mhm.
Okay, so which variable would you like to eliminate here? Which one maybe already has the appearance that it could be eliminated because they're opposite in sign?
The y's,
Yes. So what do you multiply the second equation by to get minus 2y?
positive 2.
Positive 2, yeah. The nice thing is that gets rid of the fraction there. So what I'd like you to do, Julie, is I'd like you to solve for X and then back solve this for Y.
X equals 18 and y equals -1.
You said -1?
Yes.
Okay, just checking those. Yeah, those both work. Very good. Okay, so you will get some form of a system on your test. In some form, we don't know which. Okay, kind of related to this are inequalities, systems of inequalities. So we'll just talk about those and we'll graph a few if we got time for some of that. But here's kind of a typical question that you might get. And again, with your ACT, you'll have a fifth answer here. It does say which ordered pair is a solution. That means you really do have to check them all. You probably do not want to try to graph these. That would be very, very slow.
Alright.
So unfortunately, it's a bit of work here, but we're going to work through it for at least the first few. There is kind of that BD approach, but you would have to sort of know where the points are in relation to each other. Sometimes doesn't help a ton, but it's got to work in both equations. So we'll just start with A. So for 0, 2, so is 2 less than 1/2 times 0 plus 4. Is this true? Is 2 less than 1/2 times 0 plus 4? Meaning, does it work? And I guess I'm asking you here if this is true or not.
No, it's not true.
It's not true. So that answer's out. And you really want to be quick like that with your answer. Like, okay, that's out. So let's go to the next one here. This next ordered pair. So is 0 less than 1/2 times 1 plus 4? Is that true?
Yes.
That is true. So we go on to the second equation is 0 greater than -2 times 1 plus 4.
Oh, wait. No, that's not true.
So that points out. So the nice thing now, and I know you got an extra answer here, but if C does not work, you automatically know it's D. You don't have to keep doing it. I would actually try D because the multiplying by a fraction just isn't ideal. So because D has got the 2 there. So is 4 less than 1/2 times 2 plus 4? Is that true?
Yes.
Yes. So we go on to the next one. Is 4 greater than -2 times 2 plus 4?
Yes.
Yes. Okay. So I'd like you to use that strategy and try a problem on your own here, just like that. Maybe bias yourself towards, like I said, because there was a fraction in front of X, like doing the even number ones first.
Mhm.
This one has the same thing here in it. There's a fraction in front of X. So maybe try A and C first. Not sure because the first one you may not, you may want to just go through that. I don't know. You've got to kind of figure out what you like to do. But go ahead and give this a try, please.
Is it letter D?
You're going with D, so let me check that. Let's go with the first one. 1, is that less than -3 times -1 plus 1? And that is true. And then it has to work for the second one. Is 1 less than -1/2 times -1 plus 1? And that is also true. Yeah, very good. So not too bad. I mean, it does take a little bit more time. And
Yeah.
I guess we haven't talked about that, but I'll maybe save that for the last 5 minutes for this. Okay. All right. Here's one for us to look at.
Hello.
Here we go. All right. So this one's giving you the graph, and they're saying which of these has the right direction of the inequality, because all the equations kind of look the same. I mean, there's some variation on it. I would go for the one that maybe is most straightforward here, like this horizontal line.
Mm-hmm.
That's y equals a number. And so that gets rid of C and D. And if
Okay.
it's not clear why, but we can y equals 7, that's the case there. But that doesn't give you like a ton of hope because you still are guessing unless you know exactly how to shade. So you can use the approach that we just took, which is to take a point, something like 0,4 maybe, or 0,0. It's up to you. But if you choose 0,4, which I would choose, it should work in the one, whichever one it works in, is the right answer. Whereas 0,0, you have to remember, oh yeah, it's not in the region. So if I try it and it does not work, that's my answer. That negative thinking, I don't believe works real well in these. It's better to go with the one like if this works, that's my answer. So could you try 0, 4 in A, B and see which one is correct?
It's letter B.
Okay, and how confident are you in your answer?
I'm confident.
You should be. That's great. Okay, another question here. That's not what I want. I want this right here. Okay. So before you look at the system here, focus your attention on the graph down here. So whenever an inequality, whenever you have two inequalities, they there's 4 possible regions, but they only ever intersect in one region, which kind of helps to answer this question. And so what I mean by that is like you're either shading like below this one and then below the other one, and see how it only overlaps in one region.
Mm-hmm.
But if I make the same graph here and I say, okay, below this one, but above this other one, do you see how they also only overlap in one region?
Yes.
And if we continue, it will be the same thing, that they will only ever overlap in one region.
Okay.
So like there's a question here, which is nice, but there's only ever one region where this is true. So the answer has to be A on this one without any more effort. But normally they would ask you, which region is the answer in, and then you could do something like that.
Okay.
All right. So just we never talked about this, but I would just like to spend a minute or two giving you some hints or tips on this. I strongly recommend on that you decide before you go into the exam something like the following, like, I know it and I'm going to do it, meaning like you're going to answer the question.
Okay.
That's your best case. Like there's no hesitation. You jump in the water, you swim, you're ready to go, right?
Mm-hmm.
The other end of this, which is not very positive, but it does help you in some ways. I have no idea, and no amount of time will help me. And you want to be careful with these, because sometimes there's just like it's intentionally been made disguised to be difficult, but these you should answer and move on.
Mm-hmm.
And so the rest of the questions fall into this category of either I know it, but I need time, or I don't know it, but I need time. And this is the path that I recommend in terms of how you do questions. I know the tendency is to do them linearly, but you really want to get rid of questions that you have no idea how to do right away, and well as the ones that you know how to do, and you just do them, because that leaves the most time for the questions where you just need more time to be able to work on them.
Okay.
But you should have, like, if you don't want to do this, or if you have your own, the point is to have a plan when you go in there so that you're not wasting time. You have a strategy set in place. And I'm sure you do this when you play sports. I'm sure you do this in
Mm-hmm.
other aspects of your life. So please keep that in mind here.
Yeah.
Okay, let's look at another question or two here. Some of these get really weird. All right, here we go. So we haven't done yet where you have to write the equations. So we'll look at one of those now. All right, Ryan has 1,500 yards of yarn. He wants to knit at least 2 scarves and at least 3 hats. Okay. Each scarf requires 300 yards of yarn and each hat requires 120 yards of yarn. If S represents the number of scarves and H represents the number of hats, which of the following systems of inequalities represents the situation? So always a good idea to scan the answers to kind of like look for stuff that's similar or different. Like one of the things I noticed right away is that the 3 of the 4 have these inequalities.
Mhm.
And then this other one is different. So let's see which one is right. He wants to knit at least 2 scarves and at least 3 hats. So do you see how that means that S has to be greater than or equal to 2 and H has to be greater than or equal to 3?
Mhm.
And C is out for that reason. Now, when you look at the other parts of each of these, do you see that the inequality above them is they're all kind of different. They all have the same right-hand side, but the left-hand side is different. So that left-hand side comes from the second equation or third sentence here. Can you read that and tell me which one is correct?
I don't think it's letter D.
So I'll point out that all the numbers that are in here have to be used in the answers. Like there wouldn't be, you wouldn't leave one of these out. And so when I look
Oh,
at like letter A leaves out the 120 and the 300.
mhm.
B uses the 2 and the 3, but it uses them up here and down here. We got to use all the numbers. So it's sort of a hint. The answer is D. You do kind of want to map all those numbers into the answers, whenever you can.
Okay.
All right. So that is probably it for tonight. If you have time, obviously try to do some more review on your own, but
Mhm.
use the skills you've been learning on your other preparation. Probably will apply to this test pretty well, and see how you do. I'm optimistic. I think you're gonna do pretty well because you're really working hard, and
Thank you.
you just need to like get in there and and see what happens. But sometimes taking another test, like you just do better on it. I mean, that's why
Mhm.
if you can, it's like take both tests. I tell students this, but they don't. I know it comes down to money and time and all that stuff, but it's like, why not?
Yeah.
So, all right, Julie. Well, that's it. Thanks again for letting me meet with you a little earlier tonight, and I'll send you the notes here shortly, and I'll see you next time.
Okay. Thank you so much.
You're welcome. Bye now.
Bye.